Alternator means, alternator is a generator only. So we are going to see the structure or construction of alternator. So the core of the stator is made up of CRGO, sheet steel or silicon. CRGO is cold rolled grain oriented. Grain means the surface is not going to be smooth. Surface will have lines. Okay, it is cold rolled grain oriented sheet steel or silicon steel. I know I told you we are going to use these two because we have to minimize all the eddy current loss and hysteresis loss. So for that, this material is going to be the best for the structure of your stator. The material will have very high permeability. Permeability will help in coupling of your flux and low hysteresis loss. To minimize eddy current loss, you have to use laminated core. So the core is divided into a lot of laminations which are insulated by varnish or paper. So if you can separate out the core into laminations, we can easily minimize the eddy current loss. So the laminations are stamped out in the complete rings. It's for a squirrel gauge reactor. You will have a ring and you will be connecting the conductors on both sides. You will be short circuiting. Okay, so that is what is done here. So the diagram is shown here. You can see the 3D diagram for a thing, and the open slot and semi-closed slot structure is shown here. And this is given to accommodate the conductors, armature conductors. Either you can have an open slot inside this, you will have a conductor. Here also inside this, you will have a conductor. So you can insert conductors inside these slots by using either an open slot or a semi-closed slot type uh, uh, device structure. Okay, so the whole structure is held in a cast iron frame. So fully, I'm going to use the cast iron. Inside that, the stator will be made up of sheet steel or silicon steel. So the open slots are usually preferred as the coils can be foam wound and insulated prior to packing. So open slots are mostly preferred because you can easily put the conductors inside and you can seal them so that when they won't come out that easily. Also, removal in case of any coils getting burned, the removal becomes very, very easy. So, however, such the disadvantage is the air gap will be non-smooth. So, air gap is non-smooth. The flux induction, the flux cutting your conductors will be non-smooth. So, you will have noise in the induced EMF. So, semi-closed slots give better result, but do not permit use of foam-wound coils. Semi-closed slot, you see the input is narrow, but inside it is very big. But here you see it is broad throughout. So semi-closed starts are going to be giving better result, but they don't permit foam wound means you cannot wound a coil and put it inside because the opening is very very narrow. You cannot put a coil inside directly. So that is going to be the drawback of semi-closed slot. But when you compare closed and semi-closed, semi-closed slot is going to give you better result. Then comes the rotor, though it is also a cylindrical structure which is inside the stator, leaving a very small air gap. So it is going to it houses the windings. It is going to have the windings to produce the DC magnetic field. So the rating of the rotor is 125 volt or the 250 volt, which is 0.3 to 1% of the ratings of an alternator. Alternator is a generator. Okay, so depending on the type of prime mover, we are talking about generators. So you have to rotate the mechanical shaft, correct? So depending on the type of the prime mover, there are two types of rotors. One is cylindrical or non-salient type. Second one is salient or projected pole type. See, remember we are talking about alternators here. Alternator means generator. So I need to rotate my shaft. So depending on what prime mover I am going to use for rotating my shaft, I have two types of rotor construction possible. So one is going to be cylindrical. So one is going to be cylindrical or non-salient type, and second one is going to be salient type rotor, which we are going to use for